Hello and welcome. I'm Bill Wake. We're working on a tune similarity program to try and match up various versions of tunes and decide which ones are the most similar. And we're to the point where we want to track measures. We want to do this new thing called quantizing, where we kind of take the most significant beats of a measure and compare notes at that level rather than worrying about all the intermediate smaller notes. All right. So we left off with failing tests. Let's see. Okay, that's running. There's something in our parser. Let's see. I guess we're at the note line parser. So we've introduced this thing where bar line now creates a musical element, a bar line element as it happens. So you're looking for these bars and brackets and colons, and if you find them, you save them as a bar line, and we're trying to make sure that it used to be you had an optional bar line on the front, and then you go into either notes or more bar lines, and an optional continuation character on the end. But with this, I think we need a different pattern because we should just be able to accept notes or bar lines. We don't really care whether it starts with either one. And I think there's something going on. Right now we try and break up stuff as we read it. I think that may be a mistake. I think we may need to accumulate everything and then kind of go through and parse it at a different level, kind of take the stream of stuff and decide when things happen. I don't think what we're doing quite demonstrates that's a problem yet, but I think it will be. Okay, where's note line parser tests? I'm gonna comment out or close all these. Okay, well, let's open to-do again. Should be up here. And let's find note line parser tests. Yeah, there we go. Okay, now I don't know why this is so slow. All right, but this is the one that's failing. We've got an initial bar line, and then a note A, and then another bar line. And we want to make sure we're getting those pieces back, but we're not seeing the first one because it gets ignored based on the way the grammar is. This greater, ampersand greater says you need to match both, but you're going to throw away the first one because we never cared about it before, but now we do. All right, and this is weird. Is it really trying to run? I'm going to stop, do a clean build, clean the tests, and run again. I would not have expected whatever state I left that in to care about this. Or affect it, really. I mean, it does affect it because this note reading is part of it. But I can't tell if it's really running or if it's just slow starting. All right, I'm going to go get a drink while this thing is deciding whether to do anything. And if it's not doing anything by the time I get back, we'll rework that grammar a little and see if we can fix that. All right, we're going to stop these. I'm going to run something that's kind of like completely unrelated. The grid has nothing to do with any of the notes and music. All right, so there is something going on. Let's try these. Okay, that's blowing up already. All right, I'm not totally clear if I left things in any kind of state at all, but let's simplify this. I'm going to take out the bar line. Now I'm saying you got one or more notes. Actually, I don't even know if that's true. Notes followed by spaces or bar lines. Okay, so let's take this. Make sure that balances. Okay. And let's stop and run again. That's the one that died. I don't see how anything would make an infinite loop, though. Okay, well, this is suspiciously... Let's try another. I guess tune parsing is not going to work if note parsing doesn't work. Let's see what we got checked out. Note line parser, note parser tests. I'm going to revert this. And let's see. I'm going to keep this stuff. Okay. Stop that. Source control, discard changes. And I expect now like one or two tests should fail, but the rest should be okay. Okay. Bar line captured. Okay. So A4 is not equal to bar colon. Okay. A4. Okay. So now bar line parser. Okay. Well, let's pipe that to that musical element thing we did. So it goes to musical element dot bar line with string. Okay. And I think to be compatible with the other one, it's going to return an array of those, even though it's only ever going to be one. We may be able to work around some of this at some point. Okay, so now bar line is that. Somebody should be upset. There it is. Okay, and the problem is this. Well, it's getting confused about the types. This thing is character, so I think we had to put parens in differently to make sure. I think the character was binding tighter than the other thing. Okay, so that's okay. Now, I think this is still going to have a failure mode because the initial bar line, yeah, we're not capturing anything there. Okay, so the lack of capture, is, again, this operator says require both of these to be in sequence, but ignore the one on the left. And so we're throwing away the match information we had. Now, I think, right, how's the right way to get around this? Well, this is where I was saying I think I should delete this completely. Yeah, I don't know. It works better for me. Okay, so let's try taking this part out, because now we want to allow bar lines to be first or anywhere in the middle. Doesn't matter which is first. So I feel like that was a redundant bit of parsing, or unnecessarily redundant or something. Okay, let's see. Still this one. Oh, there's a bunch of others now. Okay. Let me put that back and make sure I wasn't missing them. Okay, it really is just the one failure. Okay. So, okay, those others that may be a different problem. Let's delete that again. Oops. Well, unfortunately, the one I want to work is not working still. It's not captured. Okay, so let's look at that one first. So we say there's one or more notes with optional spaces and bar lines, and those two generate arrays of musical elements. At the end, we take that list of them and we do a flat map to take out all the elements from the arrays and put that in the score. Okay, so I don't know why we're not matching the first bar line in this one. Now let's see these. Okay, blank line found when looking for tune header. Okay, I think I've messed up the spaces. Let's put spaces in here. Oops. Match space. 0 or more of those. And followed by, so ignore the spaces and then match either notes or bar lines and turn them into a thing. Okay. Okay, that fixed all those. This one's still not happy. Why not? Parse the tune, bar colon. Okay, and he only comes up with, oh wait. Why is there's not a space in there, is there? Oh, there is. Okay. All right. So our grammar's not quite right. Yeah, and the problem is this should really be no. Oh yeah, bar line should be, we did this differently before. Bar line, let's make this one or more of these things. So the deal here in the test, these are actually, you can kind of see they're little thin spaces, but they're there between these two, but they're not between these two. And that's because with the one of, it just parsed the first one. Now we put the repeat in and we should get the rest. Okay, let's see if we do get the rest. Good. All right. So we've modified parsing to accept bar lines. Oops, I may have a crying guest here. Okay, so where's our to-do? I lost it again.
Hey, baby.
Okay, so capture bar lines. We've got bar lines are captured. Okay, so we've done that. November 1st, rabbit. Okay. Okay, so we got these. Okay, so I don't know, the quantizing. Okay, this is this challenge with this large input format. Okay, this thing of I think it's 112 pages, whatever it comes out to. There's a lot there, and I'm not going to cover all of it, but let me try and explain what I think is going on. All right, so the parser is going to handle all that stuff eventually, but now we're just focused. We focused originally on just the notes, like the pitches, and ignoring everything else. And now we're kind of backfilling in to say, okay, well, we don't really want to ignore everything else. Some of the stuff is kind of important, and bar lines are one of them because we need to know the measures. But I'm not even convinced we need to know the measures to do the quantizing. But this gives us something. Okay, so the thing I have now is I have at the top level of this, we have the notion of tune. Okay, so a tune contains a bunch of parts, and each part is like a score in itself, its own section of work. We could find an example somewhere down here, but the real example is like fiddle tunes. They often have a section repeated twice and then a B section repeated twice. So A, B, B. There's some music. Okay. Now, this one is more complicated than most. It's got 4 voices, multiple staffs, and all that. I'm not going to worry too much about it, but here's the codes for it. Well, this one doesn't define parts. Okay. So, but at any rate, you might have a part that's there that repeats or something like that. So if you had repeat statements, repeat measure bar lines, they would tell you to play the whole thing twice. I'm parsing those. They come in like this V colon. There's a P colon that says the part name. Okay, this is the A part, the B part. But you can also put them in the middle of a measure. Okay, I mean you can put them anywhere you want, but you could put them like right there in a measure, or just arbitrarily places, and that should start a new part going. Well, the way we are now, we don't really accept those. We just accept the ones that there's a on one line version like this, as opposed to this bracketed version that's in a line. Okay, so we've got a gap there. But I think what's going on. What was the example I had? Well, even the bar lines, we're accepting bar lines or notes or these slur markers or whatever else. They're all coming in this giant sequence of stuff, but there's really more of a hierarchy going on. So the hierarchy is kind of like the A part. Maybe this is the A part. One whole section of song. Then this sort of initial measure marker to there is representing. Well, I'm not sure if there's a good name for it, but there's some name that like 20th century musicians used for something similar, not construct, but I don't know what they call it, but there may be some notion, there may be some name for this thing of, I could have two repeated sections in one part. Okay, maybe it's a section, I don't know, but parts contain these sections, these closed bits of bar lines, and then within that is the measures here, and the measures we have common time here says 4/4. Well, that's a quarter note beat, a rest, a quarter note, quarter note, quarter note. So that's the 4 quarter notes. But there's that sort of structural hierarchy going on. Well, we just have a sequence, note, measure, measure, note, 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 measure, note, that stuff is all there. And then eventually we're going to have things like this. It's like that's called a fermata, but it says hold it a little extra long. You got these slurs that sort of group a melody section to say, play these in one phrase. Those cut across measures, so they're not really in the same ballpark. So I don't know. We don't represent that hierarchy, but I think we need it. Certainly, it's reasonable to ask the parts, because you can say up in the header section, you can say there's a part. The parts are A, B, B. Then define the A part, define the B part, and the whole song is play the A part twice and the B part twice. We have that, but we can't modify that to kind of account for part stuff being inserted in the middle of a phrase, or in the middle of a group of notes or whatever. And so I don't know. Let me find the parts specification. Okay. Okay, well, there's repeats. Parts should be up here somewhere. P. There it is. Okay, parts. You can have. Oh, sorry. Excuse me, just a minute. Okay. All right, so you can put this P in the tune header A, B, A, B, A, B, or A3, or AB3.CD3, all repeated twice. Okay, that's all fine. But then you can also put the part in the tune body. Okay, and somewhere there's a big old table for that. There we go. Okay, parts. Yeah, so they can be in the file header. No. The tune header, yes. Tune body, yes. Or inline, yes. Okay, so let's find inline. Inline fields, yeah. Okay, so inline fields are in these brackets, and we detect v:1, and we can do that. Detect, that's a voice marker, but whatever they are, it could be a P marker. Okay, so I don't know, that all adds up to something, right? What's it adding up to? Well, I think what it's saying is this notion of parts that we can break down and identify the starts and stuff like that. It's not really true with those inline fields, and I don't know if they're the most important thing to make this go. But I'd like to. I mean, my overall goal at this point, my overall goal for this section of work is quantize parse code, and I think I need to make my measures be measures, not like the bar line separates measures, but the measures the stuff in between, and I feel like I need to be able to get to that. Now, as I say that, I kind of am realizing I don't really care. The quantizing doesn't need to know that because I'm just saying quarter notes. All right, let's see if I can. And I don't know how much music theory to throw at everybody, but when I have measures, I'm going to say Q for quarter notes. Okay, so that measure is 4 quarter notes. This one is 4/8 notes. I'm sorry, yeah, 4/8 notes followed by 2 quarter notes. It takes the same amount of time. An eighth note is half as long as a quarter note. Okay, they use a lot of binary numbers in this section of music. You can have triplets that do 3, but most standard music is binary divisions of rhythm. Okay, and so these two are equivalent. I don't really care about the bar lines. If what I'd like to do is extract this note, this note, this note, this note, the first E, the third E, because this one corresponds to the first quarter note here, but I'm only going to take the first E to make sense of it, and then the third E, and then the Q. But I could have a measure like this that's, whoops, Q, E, Q, E, Q. Okay, and that's one quarter note, 1.5 quarter notes. I don't know if it helps to say that way. A quarter plus an eighth plus a quarter is a half plus an eighth plus another eighth is 3/4 plus another eighth is 4/4, which is the whole shooting match. Okay, but if I wanted to quantize this, the first quarter is the first one, the E is the second one, and then the second half of this quarter note is the third one, and that E gets ignored, and then the fourth one. So I don't really need the bar lines if they start with whole measures. Now there's the notion of a pickup notes. So lots of songs, the first time in, you have this da-da-dum kind of introduction where you're kind of sliding into it, and then they can repeat that or not repeat that. But it's common enough to have pickup notes that just kind of get you into the rhythm. So let's see. So quantizing, I don't know if I'm leaving too much stuff lying around. I feel like you want to know measures at some point, but maybe this doesn't need it. So I think what I'll do is I think I can keep a running kind of thing. If I asked for quarter notes, then I would do this one, this one, this one, this one, this one, 30, and so on. But I would just have to keep track of like how many beats are going on here, and which one gets provides the answer. And this one's the tricky case, sort of the arbitrary case. The first one's no problem. The second one's no problem. But the third one we have to split. We have to split this into. We almost saying it's equals E plus E, so we can take the second E and get our third quarter note pulse, and then the last one. Okay. The other thing we haven't done is we haven't captured rests and their rhythms. Okay. You can have a rest that says don't make any noise here. So boom, 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 dun 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 doom, 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 whatever the rhythms are, but you're allowed to have rests in there. So we don't do that yet. So I know we need to do that. Grace notes, I almost think that's not even part of this project. That's just something else we can and should do at some point. We parse them and ignore them right now. Okay. But it's conceivable we need them at some point. The rhythms, I'm not sure if we're capturing the rhythms on the notes. Actually, I'd be shocked if we were, because let's go look at score. Okay. So a score is a series of musical elements. So right now that's either bar lines or notes. And I can tell because it's defined up here. Musical element is a note or a bar line. Well, I've got the note. Does the note have the rhythm on it? Let's go find that out. Okay. Pitch, note name, accidental octave. There's nothing there about rhythms. Um, and I think it needs it. Okay, so we don't have any rhythms at all yet. If you ask us for the Parsons code, we just get the notes in the melody, no rhythms. All right, so we need um, capture rhythms for notes. All right, so I'm going to defer. Let's also mention inline fields for parts, etc. All right, I'm deferring these two things. I'm saying they're not really going to be part of the quantized Parsons code stuff, but we do have to capture rhythms and we do have to capture rests. Now, I think we're going to go back to our ABC. All right. And notes, externals, broken rhythm. Well, let's just start here and go. Okay, so pitch tells you the kind of note of it. It can be sharp, flat, etc. Note lengths, yeah. The unit length is the length of a note with a single letter. Okay, so sort of a default length. L1 quarter, L1 eighth, L1, yeah, not very common. You can do L16, 128, 256, 512. Okay. Though they may not be provided. Okay. If there's not one defined, we set one on the meter. Okay. Well, that tells me we need to capture M and L. Okay. Yeah, this stuff it's kind of arbitrary. Oh, golly. Okay. I mean, this is the kind of thing going on. I mean, this language ABC notation is trying to capture a lot of stuff. And I would guess, unless you got into 20th century band music or something, you never had a 2 plus 3 plus 2 over 8 rhythm to worry about. I'm trying to think if I ever saw one of these compound rhythm kind of things in any classical piano piece I worked on. I don't remember ever seeing one. I know they were done in early 20th century compositions and ongoing from there, but it's just not. It's not in the a big deal in pre 1900 music anyway. All right, but the format supports it. Okay, now this 6844. Okay, MC MC bar. Okay, so I think we'll need to parse the meter field, the note length field. Maybe we can do the note length first. Meter is not required. Free meters assumed. Put the bars anywhere you want. Okay. Yeah, and again, this is sort of showing the dependency of these things. You got to parse all this stuff before you can really do the semantics here. You can define M and L in either order, and so if you don't define an L, when you get to the bottom of the header, you realize like, oh, there was no L. I got to do this calculation thing. 4 none. Okay, default is kind of like 1/8. Okay. So okay, L colon and M colon to do on our to do. Let's get that in there. L colon length and M colon meter in tune header. And that stuff can change in the tune body too. We don't often see it but it does happen. All right. Now, let's see. We were also looking at the notes. Okay, L1/16. Right. So here, A3B says A is worth 3/16 notes, B is worth 1. CD3, C3, A2, B2, C2T. Yeah, that adds up to 16/16 notes, put it that way. Oh, these all mean the same thing. Okay. Oh, this is the dotted rhythm stuff. Oh, yeah. Okay. Yeah, so you can put 3/2. Well, 3/2 of an eighth note is 3/16. And I'm pretty sure we parse it, but we don't do anything with it. And then they have these less than, greater than things that let you get snapped rhythms. Dun, da dun, da dun, da dun, or da dun, da dun, da dun, da dun. Okay. Rests are Z or X. Okay, so Z4. Oh, okay. So capital Z says multi-measure rest. Lowercase z says single measure rest. And then X would not show anything there for there. Okay. Number of measures not given. It's one measure. Okay. Multi-measure invisible rests are X uppercase. Oh, interesting. Followed by number of measures. Okay. Yeah. Okay. Right. Okay. I think that gives us enough to work with. It's a lot. Okay. Capture notes. I guess we can move this one down. I'm going to move the example out. All right, because we can default it to 1/8, just like it does if there's nothing specified for most meters. Okay, so we'll just default to 1/8 for now, and capture rhythms based on that. Now I don't know. There's so much going on here. All right, and let's get let's find triplets. Okay. We're gonna have to do that someday too. I don't know if it's this time around. It's all just so much. I mean, I'm sorry. 3, 2, 2, G4, C2. Oh, generic toward PQR. Put P notes in the time of Q for the next R notes. Oh boy. Okay. Alrighty. Well, we can start there, I guess. Capture rhythms for notes. All right. Well, representation. I mean, we have all these possible, like you whole notes and quarter notes and eighth notes and 30 seconds and 1/256 and all that. What would be the best way? I almost think it's a multiplying kind of thing. Handle note links down to 1/28. I mean, you just don't see them, but it's again, 20th century, you started seeing more and more of this stuff. Maybe a little bit once in a while in a list or somebody, but okay. So representing this, I think we're going to say note. Let's start off with the simplest kind of thing. So these powers of twos. So I think we want to say notes are ratios. Okay, so 3/2 is a dotted eighth note. A/4 is a 32nd note. Okay. Well, I mean, this tells me divide them. I'm almost thinking it's like that length field times whatever this is. So 1/8 times 1/2 is 1/16. Okay. 1/8 times 3/2 is 3/16 dotted eighth note. Okay, so they are rhythms are kind of products. Oh boy. Let's go back to that L field. And I don't know, this whole project has been this thing of kind of struggling through what music is, what ABC is, and what our program needs to be. Okay, commonly used values. The length of a note with a single letter. 1/4, 1/8, 1/16, 1 whole. All those. Default unit length is a 16th note. Okay. Well, that's almost 1 to a power of 2 kind of thing. Yeah. Okay. So I think let's start with this notion of rhythms being a ratio of 1 and a power of 2 for now. And I think as sort of the basic note length. Okay, so a rhythm. All right, how are we going to know that we're getting a rhythm? I guess we're going to parse each note and ask it, what rhythm did you find for that? Okay, and that rhythm is going to be a ratio, so I don't think we want to divide it out per se. We may have to take out common denominators or something like that, but there's ways to do that. All right. Let's see. All right, let's get into note line parsing. Okay. Tune parsing. See, these are just the notes. It's almost like the pitches. Slurs, tuplets are allowed. We don't really support them. Rests are allowed, but we're kind of ignoring them. Okay, durations. All right, so we've checked that you can put the notes in. Let's find // Do we have one of those? Okay, rest followed by slashes. Okay. Huh, I don't have notes followed by slashes. There's some. Okay. Notes with numbers and slashes is a note. All right, note feeds to the note parser. Okay, let's go check out that thing. Note parser equals note parser main make note parser. All right, is that where we are? There, and it's got the durations. Okay. I guess I'm gonna start with some rhythm stuff. Let's make a. Well, I guess we'll drive from some tests. New file. Okay, so let's test. Let's try rhythm equality. Okay, and I learned this pattern from Jim Shore of just consistently testing equality. You define two things the same, so let rhythm one, I'll spell it if I can. Rhythm one is a rhythm 1/32, and rhythm 2, well, let's say rhythm 1A, rhythm 1B is the same thing, and then rhythm 2 is different, 4/16. Okay. Then the assertions are rhythm 1A should be equal to rhythm 1B, and not equal, rhythm 1A should not be equal to rhythm 2. Okay, so that gives us a starting point. And I don't know, usually I try and start a little higher up, but I think we know enough about rhythms that we can start making some inroads on this and get the class defined and comparable and usable from that point of view. Okay, rhythm. Okay, so let's make let's just say struct rhythm. And this is numerator of int and denominator int, and then we gave it an init. I guess the whole struct should be public. Okay. All right. All right. Let's just get this together so far. This should be. Oh, we need to conform to equatable. Good. Okay. And it's pretty conventional to make these extensions. Make rhythm be equatable, and it's just got two integers in it, so it can auto-generate that. And that should be fine. Oops. Well. Oh, good point. Okay. All right, now this test should be running. Cancel. Someday I'm going to remember this, or there must be some configuration. I don't know. Rhythm is fine, but rhythm tests needs to be in all these. Okay, let's try that again. Okay, it fails. Okay, yeah, for not very good reasons, but let's make it work. Okay, so obviously this should be numerator and denominator. All right, now that's going to pass, I believe. Should it pass? Well, our test doesn't establish it. Okay, let's make a call. So I think this is the duration. Um, I think they should be equal if they reduce to the same value. So let's let's make this rhythm 1 and rhythm 2. So 4/16 is the same as 1/4, right? All right, and so rhythm 1 should be equal to rhythm 2. This should fail. Okay. Um, so my claim, oh boy, and this is where you try and pull out these distinctions. Um, it's clear to me that at some point we need to be able to say this is a 4/16 and a 1/4, and they should be the same. It's also kind of clear to me that there could be situations where you wrote them differently and maybe you care that they're different. And I don't know, like, should rhythm and duration, should I distinguish those concepts where duration has to do this thing and rhythm doesn't, you know? Because that would say, oh, if you write 4/16, um, that's going to be different than running a quarter, and they shouldn't be treated the same. And duration would say, no, they are the same because they take the same amount of time. All right. Um, I think I'm going to do this. And I don't remember what equatable generates. Somewhere it'll tell me. Yeah, I need this. Because I'm overwriting it, basically. Okay. And what I want to say, and I'm going back to, like, third grade math or whatever, A over B equals C over D if A times D equals B times C. Is that right? um, okay. Right. So return LHS dot numerator times RHS dot denominator equals LHS dot denominator times RHS dot numerator. Okay. And so let's put that over here. 1 times 16 equals 4 times 4. Okay, so you cross multiply. I don't think the numbers will be getting big enough to worry about the capacity of int, so I'm not going to worry about it further, but this should do that. Okay. Now, I know I'm going to have to multiply them at some point. I don't really have justification. I really wanted to get enough to push this into existence so I could start capturing it on my notes.
Turn the light on.
Okay.
He's working, so we have to be quiet.
All right. I tell you what, we're kind of due for a break. Let's take a 3-minute break, and we'll come back and start applying these rhythms. All right. So see you in about 3 minutes, top of the hour. Hey, welcome back. All right. So I think, boy, I think what we want to say is that notes are the things that should know the durations. And I'm kind of basing this on all the stuff that gets attached to notes, the rhythms and all that stuff is part of the note. And let's find that song example again. I wish I could put little bookmarks in here. All right. So we got quarter note, quarter note, quarter note, 3/4, dotted. So it's three halves as long as a quarter note, or as a half note. It's got the open circle. I think we need, well, I need to differentiate. The notion of the default note length is, it's a parsing notion. The notion of the actual rhythm is a domain notion. And I need to keep that straight in my head. Not sure I even explain it well enough to make it straight in my head or your head, but there's nothing implicit in this that tells us the note written is a quarter note. That's up here. This thing, common meter, see, it's B2, so it's defaulting to eighth note, even though the notes we see on the page are all quarter notes or bigger. Well, in the first line anyway. Okay, so I think somebody should come in and just tell us the absolute value of this, even if they have to do some multiplication themselves. So B2 says default to eighth note times 2, 2/8, 1/4, and that's this. Okay. Let's see. Whoops. I'm getting lost here. There we go. Okay. So I believe this rhythm has to be part of a note. Right now, note doesn't have that concept. And I think we'll just default it. I think we're going to introduce it and then default it. I don't know if I need to do anything for it now. Let's do that. Rhythm equals rhythm one, let's say 1/4 note. Okay, I don't know the right answer. There is none. There's no implicit thing in music to say it's a quarter note. I'm only doing quarter note because that common time, the C is 4/4, is a pretty common rhythm. Okay, but mostly my notes aren't going to care because I don't use them in tests. So that should be a neutral change. Everybody should already have that. Maybe the equality test is insufficient. String convertible, equatable. Okay. We probably should check that two notes with different rhythms are different. Okay, so let's find note tests. That's pitches. Here's note numbers. Same rhythm to maybe I'll say equality. Notes must have same rhythm. Okay, so let's make a couple of notes. And I don't know if I can, I think I can say note. Note name C, octave 4. What do I don't have to put key, accidental. Can I say rhythm? Okay, let's go back to note. I think I can do that. Okay. Wait. How did that pass? Oh, I don't make any assertions yet. Okay. Never used. Yeah, right. Okay, so note 1A should be equal to note 1B, and then note 1A should not be equal to note 2. That should fail. I don't know if we need to put that in the string description too, maybe. Let's see what we do. Oh, it's custom string. So we do look at this. My fear is if I put something like the rhythm, I'm going to break a bunch of tests if I put the rhythm in, but the test here needs to check this. LHS.rhythm. RHS.rhythm. We don't have a field for it yet. Rhythm of type rhythm. And then okay, now that should pass. All right, that does make me want to put a two string on rhythm though. And I'm okay to check that. Well, let's rhythm string convertible. Actually, let's just do it this way. Assert equal. Take that. And this should be dot. I'm going to borrow from here. Rhythm. Okay. I think this is right for now. Um, I'm saying we don't need to reduce it as of yet. So I think that's how we want it to be. These should fail. All right. With question marks. Yep. So that should be numerator over denominator. Okay, and that should pass. All right, so add rhythm class with comparison and string. Make sure note uses it for comparison. Haven't pushed enough today. Okay. Let's go back to note tests. Okay. Equal notes must have same rhythm. Yes. All right. Now, somewhere in here, I'm going to change the key thing to note. So this is how we treat optional arguments. I'm going to say you can put the actual keyword in there. That looks a bit better as you're choosing which ones to do or not do, but it may break some places. I'm not quite sure how they, yeah. Oops. I guess it will fix for me. Missed one somewhere, I guess. No. Okay, so now notes represent rhythms. That's a good step forward. Um, but the parser needs to do something with them. And we saw all those here somewhere. There we go. Okay, so now, let's see note. Note runs our note parser, which produces notes. So the note parser should have done the work already. Okay, note parser is here. Okay, when it creates a note, oh, there's global state it depends on. That's the problem. Okay, so here it's capturing the digits. Numeric duration is digits followed by optional slash followed by digits, and we're calling something to do this. What is that doing? Oh, interesting. Duration. Oh. Okay. We didn't really take duration into account so far. Let's find usages. Okay. We're using it. Right. Okay. So we're mostly ignoring it. Slash duration. Multiple slashes. Yeah. Okay. I think the time has come to reference rhythm. So let's go see duration. Let's make this rhythm. See what breaks. Okay. Let's say rhythm. Okay. And we're going to return. Well, this is the numeric. We want the numeric value of this. Okay. So I think what we want to do is let's let numerator equal let's call this top and bottom, I guess. Or upper and lower. Okay. So the numerator is going to be equal to let's take upper. Well, let's turn it into a string. Let's see what we can do with int. Int from I don't see one that's a string. Okay. Int 32 from a string. Okay, so int of string of upper. Cannot find upper. Oh, okay. That's really just a pair. Okay, so we'll decode that. We'll get the upper numerator. The lower number, well, the denominator of this thing, if they don't specify it, I think we need I think we're going to need to configure this. I don't know if it's in the parser. Somehow it has to get to it. What's tune state? Could I put it in there? That may be the way to do it. Okay, let's go back. Okay, so let's let denominator equal int of string of lower else 1. So if they don't have one, I think with optional, unwrap to a value of type character. Can I do this? Oh, well, that would be interesting. Okay, so I'm defaulting everything to ones. Default is 1, 1. Exact matches to initializer. Why would that not work? Let's try it off there. Okay, so we'll default the denominator to 1. All right, now we need to return it. Okay, I'm going to let it just be whatever it says for a moment. Return rhythm of numerator denominator. Okay, so given well, we're going to assume these conversions are okay. We parse them into strings of digits, so I'm pretty confident that way. You could blow it up, I guess, but okay. All right, so what I've said is if you've got characters, you're going to break out the characters, turn them into a string, turn that into an integer, and if the optional one is not provided, then just default it to 1. Okay, and then return that rhythm. Now, that's not quite right in the parsing sense that really there's sort of a default rhythm and we got to take that into account. But this will get us moving forward. Okay, cannot convert characters to ints. Okay, so this one slash digits is duration nothing. Okay, this is one or more slashes. Okay, and I don't know if I'm jumping too far. Okay, a bunch of slashes. We want to make a rhythm. I don't know if I have an integer version of this. Power function. I'm sure POW returns doubles. Yeah. It's really good enough. Um, is that quite right? I want to do the $0 count. Okay, so if there are zero, it left shifts zero. Um, we want one to be zero. So I think we actually want to do this. Okay, so if they have one slash, we take one left shifted one, that's two. If we have two slashes, that's one left shifted two. Okay, I think that will do it. And maybe we may backfill some tests. Okay, and in this case, the slash duration, this is I think we don't need the match. We don't need the slash. We know there's just one slash, so we don't really need it. We'll just take the digits and we'll make that one, and then $0 is the digits. So we'll take int of string of $0. Okay. I think. Oh, what do we got? Oh, I don't need this. We're referencing $0. Okay. I think we should be good. Nope, somebody's still complaining. Oh, int. Okay. Okay. We're caught back up. Okay, so add make nodes remember their duration. All right, and I want to get rid of that word duration. Okay, so let's find duration. Is that up here? Nope. We're hoping nobody uses it. Okay. And numeric duration, we make a rhythm. Okay. I think that's good. Let's make. And like I said, maybe duration and rhythm are separate things, and at some point we'll have to do it. But I think what we've done correctly is the rhythm. The rhythm is purely a domain concept at this point, and you just tell it exactly what you want. We don't fool around too much with it. We're not dependent on how it gets parsed or any of that stuff. The parsing does its thing, matches everything, and then figures out what to call it. Okay. All right. So Notes, no durations. Okay, so let me. All right, let's look at our to do. Okay, capture rhythms for notes. I think we've kind of done that now. Let's go to the parser. He's got the rhythm. He's got a rhythm. I don't think the note does it though, does it? Where do we build the note? Nope. Okay, let's find a test for this then. Notes, octaves, slashes. Okay, this should be, the rhythm should be 32/4. Is that right? Um, that can't be right. Note C. No, I don't know where 32/4 is coming from. I think it's probably going to be 32/1. I don't know how I get access to that state. All right. This is where this length notion comes in. 32 should really be 32/1 times the length, the assumed length or default length. Okay. So we don't have the notion of time multiplication of rhythms yet. Maybe I just have to start making this go. 32. I'm going to say eighths. Sorry, if the default rhythm is eighths, somehow we have to say that. Okay, so note parser, it knows tune state coming in. So let's find who creates a note parser. Well, we know that's in here. No, it's an ABC. Note parser is on note parser main. Oh, what? Note parser. Right, but somebody had to create a note parser. Note parser of self. Okay, that's on the ABC parser. Has tune state. Okay. Right. And okay. So I guess I want to see something fail, right? Let's go back to note parser tests. This should be 32/8. This should be 3/16. This should be 1/16. Okay, 1/16. This should be rhythm. Oh, it deleted it on me. Now I know why. Okay. That goes in here. Okay, and the rhythm is 1/8 divided by 4 is 1/32. And this one is divided by 2, 4, 8. 1/8 divided by an eighth is a 64th. Okay. Right. Now, I think these will fail. Okay. Because nobody's looking at that tune state and we don't have anything in it yet. And it might have build. Does not conform. Okay, where's tune state? Note length and current key. Okay. One-eighth. Okay, so our default note length is 1/8. Our rhythm calculation should take that into account. I'm very, very sure they don't. Okay, good. And it looks like that's kind of the only thing failing. So I'm kind of happy there. And this is where this description would be better if it had. It's not telling us why. It's just we have the note, but we don't have the rhythm. Okay. And I think we need to, in the note parser, okay, this is really numerator times tune state dot note length dot numerator. And denominator times tune state dot note length dot denominator. Okay, we can probably do better on this, but All right, let's make this go. Okay. Now I'm gonna wish I had that. We don't know what we're getting. Okay, so let's. And actually, this is the only one of several that does this. Okay. I'm going to put this in. And it's going to break a bunch of tests. But I need to see some answers here first. So let's get this. Okay, now 1/4. 1/4. Okay, so we're getting some default value. Alrighty, so let's go back to our parser. The note parser, we got make numeric duration, does the right thing. These do not. Okay, so my proposal is rhythm should take I think it should take another argument, which is an optional rhythm that's sort of the base rhythm. Okay, so let's add that. All right, so I'm going to say let rhythm. I think I could type this by now. I've probably given myself finger memory that's wrong. Okay, let's say 3/8 times a rhythm of 1/4 and let's make sure that's the same as 3/32. Construction with base rhythm, put it that way. Okay, that's not allowed. We need it. I got to do this differently. Setting up some recursive situation that's just going to go bad. Denominator of int and a base rhythm of type rhythm. And we want to say self.numerator equals numerator times base rhythm.numerator, and self.denominator equals denominator times base rhythm.denominator. Okay. I think that's better. Okay. And this should pass. All right. Now this, I think is still going to fail, right? Because our note parser he's building rhythm of all this stuff, but he should be looking at tune state dot note length. Okay, and this should be self.tune state.note length. Okay, so wherever we're capturing rhythms, we need to take into account that possibility. Let's make sure this does. Yes. So this code now we can simplify. Tune state note length. Now I think that test is going to pass, but anybody else who looks at, okay, it's not. 1/4 is not equal to 32/8. Is my math the problem? Probably. 1/4. No, it's still 1/4. Okay, so somewhere we're not putting that in the note. Okay, so that's whoever builds the note. Note parser. Build note. Okay, he's got upper octave mode duration. Oh, he's not even looking at duration. Okay. So, let's check these other ones out. I think they're probably just the rhythm thing. Okay, A4, 1/4. I don't think I use that a lot. Yeah, okay. What's down here? Oh, iOS test. Okay. So this one. Right, so our note parser now. So what happens is we capture the accidental, the letter name, the octave modifier, and we capture and throw away the duration. Well, we don't want to throw that away anymore. Now, build note doesn't take it into account. It's got the accidental, this, the characters. String int is the octave and name. Characters. Note base octave, octaves, and let's add duration. I think the complaint is build note doesn't know what to do with it yet. Okay, accidental, optional, string int coming from no upper letter parser, octave modifier parser, and now rhythm. Okay, and then this should be rhythm. Okay, so never used, right? Now why is that still complaining? Okay, so if Okay, I want that rhythm to go in here, but he's optional. Okay, so let's make this rhythm else. If he's not found, then we want to use tune state dot note length. Okay, so if there's no rhythm specified, we default to the real one. All right, what's your problem? Non-optional type. Oh, this is rhythm question mark. That should make this happy. No. How about AKA? Optional, accidental, optional, rhythm, array of character, note. I think that's better. Okay, build note. Accidental, note base octave, octaves, duration. Duration is optional, just like accidental parser. Okay, so we accidental note name base octave, octave modifiers, rhythm. Let's get the type of this. This type is rhythm question mark. Accidental question mark string int character rhythm question mark. Going to note to expected value. Where's my AKA? AKA optional accidental string int array of character. Wait, I lost a parend. Oh yeah. Oy oy. Yuck. Character. That's the first one. That should be the second one. There should be a third one. Now this one gets an extra one. And this is all the semantics routines. It's basically this craziness is matching the structure of our parser here. And when it has two sequences, it puts them in a pair with the inner one and then the outer one. But it doesn't take a sequence of them and make them into a flat thing. It's got them nested. Ugh. All right, but the good news is it should work. Okay. Wowzers. Everybody's unhappy except okay, this one's happy. The others are not. So I think it's probably string stuff. Okay, tune 27, title, alternate title, key G. That's the same. A4 1/8, F4 1/8 is not equal to 1/4. All right, I think, do we build ABC parser somewhere here? ABC parser, yes. We need to set the default length. Wait a minute. These are coming up 1/8, which is good. Oh, my expected value must be. Yeah. Okay, these need to be eighth notes. because they are implicitly eighth notes from the the setup, and so maybe rhythm should default to eighth note as well. Note does that. The default rhythm for a note is an eighth note. I think that's reasonable given the default. Well, it's certainly the parser default, but I think even in a musical sense, it's probably reasonable. Mostly this affects tests specifying their values and um, not the parsing process. So I think it's okay. Well, it's more okay than the other. All right, what's the problem here? Oh, this is now 1/8. Yeah, that's true. Well, this is kind of the same thing. Check tune parsing, expected notes. These should be eighth notes now. All right, let's see what we got. Allows bar lines. Well, this may be an octave thing too. Oh no, these 2, 4. Okay. The old Xcode test runner used to put all the messages in there where they were from. Now you got to go up and find the thing that's actually doing it. Okay. Well, check note parsing. Expected notes. Now they're defaulting to eighth notes. Okay, allows bar lines. This is my GFG is eighths. Well, that's actually true. Two notes filter is note. I mean, I'm really kind of checking the. Well, let's see. The bomb one, I think, is easier. This is not. The 2 is not really relevant. And the 4 here. We're not trying to parse that. There's this invisible character here that we've made slightly more visible here. So I think he doesn't care about those durations and doesn't need to reflect it. Bar lines, again, I don't think we're not trying to deal with durations in this. So let's take them out. We could fix it by making our assertion more explicit about durations, but really we're just trying to make sure this bar got processed with or without spaces. Okay, so that should pass. Okay, so let's see what we got for check-in. All right, we're going to do a little walkthrough because it's a little bigger step. All right, so we added the notion of a default note length to the tune state. which is part of the parser state. In here, we make numeric duration now returns the proper rhythm instead of this denominator question mark thing we had. Okay. Slash duration builds up a rhythm, takes into account the default. Same thing for slashes by themselves. Good. Build note, we added this notion of an optional rhythm, and we incorporated in picking the default length otherwise. Okay. And let's see, domain. Okay, so our rhythms, we added the rhythms to the notes with a default of 1/8 and put that in the printout so we can test a little better. We added another constructor for rhythm that takes a base rhythm. We made our assertions include the rhythm durations. Good. And we added a test for this new constructor we built. Okay. So make rhythm parsing be reflected in the notes rhythm, including taking into account the default rhythm from tune state. Okay, well, that's a good place to be. Capture rhythms for notes. I believe we've done that. Now I want to capture rests and rhythms for rests. Okay, so note parser actually deals with that. Oh, my to-do is, I need to put this down. Sorry, make it a little more reflective of what we're up to. Okay, so note parser. We gotta find rests. No, I thought we took those into account. Find X. There's an X note line parser. Rest parser. Okay, so we don't actually have an element for rests. I think we need to do that. Okay, so here's the rest parser. Rest parser turns into nothing. Or note parser turns into that. And I'll probably lose the formatting as I go, but these are parallel. Okay, so basically our rests do nothing, they just parse. Match slashes and optional digits. This is not quite accurate, is it? Take the same complexity as rhythms do. Rest 0x notated in length exactly the same way. Which is good in a way. But it tells me we need to we kind of need to do all this stuff, right? And maybe we can pull this thing out. Duration is numeric duration or slash duration. And in the end, it gives you a rhythm one way or the other. Okay, I think maybe that is the concept we're looking for. Is a duration parser. Um, and if we call it, then it returns a rhythm and it gets called into build note here. And I guess our rests will have to do something similar, but they're going to rely on all the same mechanism. So let's pull out duration parser. Um, okay, so I'm going to say duration parser. It should be the real one. We know we'll need p-combo. Okay, so note parser. Well, it needs the tune state for sure. And it needs this for sure. Let's pull that stuff in. Okay, so tune state numeric duration. Then all this stuff. Note parser. Okay, bind character to rhythm. Okay, so if you call this, if you call make, okay, so the bind gives us the parser itself built on its parser method, so we can just use the simple description rather than the complicated one that's the reality. Okay. That's good. Now, I think we need to pass. Well, let's see. Tune state. Note parser. Tone, note length, note length, note length. Tune state, note length. I guess we need it there. We chose to say it was optional, so I guess we have to be responsible there. Okay, so I think we need to pass in a duration parser. And it was the bind character to rhythm. And let duration of C bind character to rhythm. And store it. Maybe the word here, duration parser, just to keep it clear. Okay. There should be some callers that are upset. Whoops. Cbind already has character. And self because it has the tune state, and then this one needs duration parser. Okay, now it's not using it, so there's no duration parser is cbind of rhythm. Cannot convert value of type duration parser. Oh, we have to do the same thing. Okay, so that's duration parser. Nobody should mind because nobody's using it. We're just passing it around. Okay, so introduce duration parser, but not yet used. Okay, so here's duration parser. That's enough. Okay, now ABC parser, no, note parser is calling. I should be able to comment out all this. It's using duration. Now it's a local variable, but with it commented out, it's going to access this one. Okay, so that and duration. This should work, but it's definitely using more stuff. Did you actually run? I guess so. Okay. Delete. Okay, so should run. Okay, make note parser use duration parser. All right, now note parser, note line parser. It's open to me if this should do something. Rest parser. Okay. Again, I think we're going to introduce something. Just like we have musical element.note, we're going to add dot rest, I guess. And it's going to have a duration as its only argument. Okay. So this is, well, I think this is optional duration. Do we have duration here? Note parser. I guess we want to get a duration parser in here too. Okay, so if we pass that in, we want to use it. Okay, so we're saying you will pass it in with the note parser. Now this can be cbind as well. Well, let's save that. Let's find the places that need to pass this in. Yep. ABC parser. Okay, so note line parser needs a duration parser. Okay, and note line parser is not using it yet, just like the other. All right, but I think Z is followed by basically an optional duration. Let's make sure that all hangs together. Oh, fatal error. Now nil. Rest parser. How is this nil? You passed in duration. Well, what's nil? Line 30. It sure looks like nil. How is that nil? You have to build it and you have to pass it in up here. Okay. Let's find the caller of this. Oh, well, okay. That's good reason. Okay, so now we're passing in duration. All right, we're closed in. Let's see, we got an optional duration here. And then when we get the rest parser, we're throwing it away. Okay, so I think we got to find tests that use rests in them. Okay, so let's look for Z is probably obscure enough. Text. Well, we definitely have them there. Tests. Rest can be followed by slashes. Okay, I think check tune parsing. It only comes up with the A. Okay, this is going to be interesting. We need to represent this notion of a rest. Okay, so let's find, I think it's tune. Tune has this, no, how about score? Musical elements. Okay, there's note, but I think we need rest with a rhythm. Okay, and we don't have a description for it yet. I don't know. I wanted to use underscore, but that's kind of taken. Um, boy. Let's do what we did here. Um, okay, so we're just going to put something in. I'm just trying to get this element there. All right, does that affect anybody? Well, yeah, you can't type an arbitrary X in the middle of your file. Okay, good. Good. Okay, so add rest to musical elements. All right, and now well, where were those tests? Rest can be followed by these things. Okay, but what we're getting is just the hmm. I don't know. Tune parsing is coming up with the notes. That's what we're not doing now. Maybe we should. Um, expected note names dot map. This. I really want to capture the rests on there. Maybe I'm stepping too big a step on this. So tune parsing passes expected note names. Notice I can't get the durations out of that. So I'm gonna check rest parsing. It's gonna be its own thing. Wherever that is. Okay, let's put a check rest parsing. You're gonna give me an input string. And I think you're going to give me an expected rhythm. Expected rhythm and a what? Uh, sort of to distinguish these cases. I'll implement them one at a time, I guess. But okay. I'm expecting. Oh, expected rhythm of type rhythm. All right. So I'm going to have to do something like check tune parsing. So let's go find that. Well, let's just take the body and see what we get. Tune parse header lines is empty. Note lines is input. Okay. And then we got expected rhythm is already a rhythm, so we don't need that. Expected tune. Right, I don't think we even need that. Well, no, maybe we do. Maybe let expected rest equal dot musical element dot rest of expected rhythm. Okay, and then this should just be expected rhythm rest. Can't do that. Has no subscript. Okay. Notes is a score. Okay. Cannot convert score element throws to musical element. Is that do it? Maybe this is enough. Well, if that's enough, then it ought to just be tune. Okay, let's see if that does it. Check rest. Parsing. Yeah. I don't think I need the notes. Okay. This has two cases. Z slash expected rhythm is rhythm. Well, it's 1/8 divided by 2, so 1/16 slash duration. Okay, now this one is x slash 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 multiply slash duration. Okay, and his answer should be a rhythm. Okay, 16 32nd 64th. Okay, z/2. Should be 1/16. Um, 8 times 24. 192. Am I multiplying correctly? Slash duration with following digits. Yes, C32. We don't TF. This is a rhythm. 32 190 seconds. If my multiplication was right. 24 times 16 is 3 times 8 times 16, which is 3 times 128. No, is that right? Okay, I'm going to paper. Excuse me. 24 times 16. 4 is over. My first digit's wrong. 124. 24. 264. Okay. I'm happier here. What's the matter? Check. Rest parsing. Okay. Let's add check rest parsing here. For input of Z should be rhythm 1/8. Standalone Z. X by itself should be rhythm 1/8. Okay. Every single one wrong. Okay, but I know why. Because we don't save anything. Okay, where's this down here? Okay, rest can be followed by slash duration. Notes colon 1/16. Okay. Empty notes. Yes. Okay. I'm realizing now I'm over time already. So this will give us a place to start. But I think what we see, the critical line here is this one, right? Let's throw away the rests. Okay. We've gone to the trouble to calculate their durations. Coming back from duration is a rhythm. We have it in our hand, but we throw it away. So we'll deal with that starting next time. So I think we're closing in on the rests anyway. So thanks for joining. Next time is, let's see, I didn't check my UTC, but it's the same time it's been from my perspective in the U.S. For what it's worth. It's 1 to 3:30 p.m. Eastern Daylight Time, and it was 6 to 8:30 p.m. UTC. I'm not quite sure where that leaves things now. So UTC should be absolute, right? You got me. Okay, but anyway, 6 to 8:30 p.m. UTC, I think. I'll double check. But thanks for joining today, and I hope I catch you in the future. Take care. Bye-bye.